Let's deal with this question from JEST 2012. Here we are given 5 identical spin half particles subject to 1D simple harmonic oscillator potential, and we have to find the ground state energy. We know that identical spin half particles obey Pauli exclusion principle, which states that for a particle of spin S, two S plus 1 particles can be put into one state. 2s plus 1 particles can be put into one state. So this is coming from Pauli exclusion principle for identical fermions. In our case, S is equal to 1 by 2. This implies spin degeneracy G is equal to 2 into 1 by 2 plus 1, which is equal to 2. So we can put 2 particles per state. Maximum you can put 2 particles per state. In the one-dimensional harmonic oscillator, n starts from 0. So we have n equal to 0, then we have n equal to 1 state, and then we have n equal to 2 states, and so on. So the first 2 particles we can put in n equal to 0, the next 2 particles we can put in n equal to 1, and the final particle will go into n equal to 2 state. Of course, we can put one particle in n equal to 5th state, another particle in n equal to 8th state, but we are trying to minimize the energy here because we need ground state energy. So the first 2 particles we will put in n equal to 0, the least energy state. The next 2 will go in the next energy higher energy state, and the final will go into n equal to 2 state. The nth level has an energy En is equal to n plus 1 by 2 h cross omega in the case of a one-dimensional harmonic oscillator for a frequency of omega, with a frequency of omega. So E0 is equal to 0 plus 1 by 2 h cross omega, which is 1 by 2 h cross omega. E1 is equal to 1 plus 1 by 2 h cross omega, which is 3 by 2 h cross omega. And E2 is equal to 2 plus 1 by 2 h cross omega, which is 5 by 2 h cross omega. So ground state energy for 5 identical spin-half particles is equal to, there are 2 particles in E0 state, there are 2 particles in E1 state, and there is 1 particle in state with energy E2. So this is equal to 2 times 1 by 2 h cross omega plus 2 times 3 by 2 h cross omega plus 1 times 5 by 2 h cross omega. This is equal to h cross omega plus 3h cross omega plus 5 by 2 h cross omega. This is equal to 13 by 2 h cross omega. The correct option is B, 13 by 2 h cross omega.